let's see. So if you guys have additional topics, I can write them down for you. Otherwise, we can start picking through the listed topics. Matthew?
I just would like precision on LTTNG GUI. Is that for controlling? Is it for prove off that one? I can do it.
You did. So do you want to provide a bit more context about what you mean by LTTNG graphical user interface, I guess?
Yeah, so I would like to see a GUI version of the CLI, basically. So like with the CLI, you need to, well, what I do is I write like the script and then the make file on top, just to make my life easier when I do like traces, so that my traces are contained or mostly contained within the trace program itself. So that's why I want a GUI so that it's easier for me to configure the options and all the parameters.
Okay, so basically graphical user interface to control or set up your tracing.
Yeah.
So any other topics that you guys want listed, or we start picking through those? So we can start with this one as we saw the graphical user interface to set up tracing. Let's see. So that actually segues into various topics we've discussed internally in the past years at HHS and with also people we've been working with. So the notion of setting up profiles for sessions. I mean, what would be missing in order to do a graphical user interface, I think, is a good understanding of what people want to achieve while using that interface. Because we can do an interface that's as bad in text format or in graphical format, right? If we don't understand the user requirements. So I would say the first step before stepping into any kind of implementation or prototype is understanding what people would want it to do. And maybe part of the answer to that question would be a graphical user interface, but maybe part of the answer would also be additional infrastructure that would be useful for both a command line interface, a library, and a graphical user interface. Erika?
Yeah, I think something that's really helpful for us, I work for ACS, by the way, is knowing, like you're saying you have scripts that are sort of built on top. What's really interesting for us is like seeing those scripts, like basically what questions, what are the gaps that you have filled with your custom code, and like which gaps make sense to like move upstream. And I think, so sort of a different way of saying that for me is, what questions are you trying to answer? And that's really helpful for us, because that tells us which pieces are missing or where the gaps are. And like, again, like to me, something that I always try to ask for when I'm speaking to users is, please tell me the symptoms, don't guess a diagnosis. So like, tell me what's annoying, tell me what's frustrating, tell me where the gaps are, tell me how you're fixing them. And then we can like figure out what an appropriate diagnosis is together. Because I think knowing what the problem is really helpful for figuring out what an appropriate solution is. So if you want to talk afterwards, like, or share your script with us, I would love to see that. I don't know if that is.
Yeah, that's perfect. Matthew?
I would like to add that An made a really cool website for configuring LTTNG that we're using. Like we're using it internally at Ericsson because, and it's really just remembering the parameters for when we're doing test study runs. I'm trying to remember the URL though. Would you have it? Would we be able to share it either with the LTTNG on that.
But it's basically a CLI generator.
Yeah.
Because one of the problems as well is that it's hard to remember the options and the parameters, what you need to put in. And if you want to know that, then you will have to go through the documentation again. So it's a bit of like time spent on understanding.
Just for giggles, if you go on GitHub and you look up SIG profile, you're going to find at least 80 scripts on how to do LTNG call stack profiling. So,
Yeah.
Yes. So there was a tool developed a few years ago called TNG Utils that was made to provide a CLI that's kind of easier to use and provide profiles that are already like preload some libraries, for example, C profile, or add specific, but it's mainly to run scripts or programs, so it doesn't fit every use case, definitely for LTNG. But for example, it can be used with a stage on Windows 7. And one of the other issues I saw, setting up benchmarks and stuff like that, was the Python bindings that they are not available like right out of the box. And so you need to recompile LTNG if you want to use that. That's one issue. Otherwise, yeah, they're definitely great. When they are available, the Python bindings can definitely use to automate scripts and automate it.
So making the Python bindings a first-class citizen of LTTNG rather than something that's not necessarily available by default.
And also, it would make like for the implementation of LTNG details. For now, it's just output comments. It was not implemented using the Python bindings because bindings are not available by default.
Yeah. Okay. Thank you. Other questions on this specific topic? Or
I'm going to be
yes.
sharing on the chat.
Sorry.
I'm going to be sharing on the chat the web app. If you could just pop it up, I think that would be able to get a conversation going. I just have to fight with Teams a little more.
I just have no clue how to do that. So
That's good, because I have no clue either, and I'm frustrated with Teams right now.
sorry.
Yeah.
So I'm not going to do anything to this. Sorry.
Okay, never mind then.
You can share on the chat.
I'll share on the chat, and everyone online, all the fine people, the hundreds and thousands of people online will be able to watch.
Yeah, that's fine.
I'm guessing what I'm trying to get here is that we want to eliminate the operational overhead when we're using LTTNG.
Yes.
Yeah.
What I'm concerned about is if we now narrow down our solution to a specific small subset of use cases, that we end up kind of missing very important use cases. So it's okay not to cover everything, but I think we need to do a clear analysis of a set of user requirements in order to be able to figure out a solution that facilitate the life for most common use cases. So that's where I think we need to do a deeper analysis of the user requirements before we end up doing a solution. Yes, Erika?
I don't even think it necessarily needs to be like, just as sort of a counterpoint to that, like I don't think it necessarily needs to be super exhaustively explored, but I think that we could just try some lightweight things, you know, like LTTNG utils already exist.
Yep.
Like even writing a blog post about it and more like making sure it doesn't die, you know what I mean?
Yeah.
Like I know it's Genevieve, I don't know if Genevieve is still working on it or like, do you guys keep it alive?
Yeah, I accepted it for the rest of time ago.
Renaissance started using it.
You're the maintainer?
Yeah.
Or well, you're responsible.
Yeah.
You use it, so
He-
therefore you become
He's
the
the
maintainer.
default.
Okay.
Yeah. And also I've begun to rewrite it.
Oh, thank you.
But the thing is, I was wondering, well, whether to use or no binding, but they are not available. So right now it's kind of pause. That's it. But definitely, if they go available by default, then it will make it much easier to implement new features.
Because the students use it pretty heavily, right?
It's used in the tutorials like that we have.
Okay. But do you know if like the people do research?
Oh, moi j'ai pas thinking this
Some do.
chat
Okay. Just to get a reference of like how helpful it is in the general population.
We could do a quick show of hands. Who has a hard time with this CNG CLF? First of all, who's here? Twice as many hands up.
J'ai pas la même impression.
Yeah, I think that's.
Okay, next topic, or anything else to add to this discussion point? So if not, let's go to S-frame syscall. Steven?
Turn around.
Oh yeah, tracing configurator. Okay.
I just want to preface there's some problem.
Yeah, but it makes my life so much better than not having it.
Okay, so cool. Next topic will be S-frame system calls. So the way S-frame currently works is I mentioned that there's two tables. It's in the ELF file. So the ELF, when you build, with today, the utils actually, as of today, has S-frame support. There's a way that you can, when you build GCC dash, was it G or W or dash W, whatever, yeah, dash W, capital W, S-frames, you'll get your S-frame binary in there. And the kernel can see that. The problem is we have libraries. So if you take all the patches I have and apply it to the kernel, and you build your applications with S-frames, you'll see the S-frame stack walking working for the applications that are built statically. For dynamic linking, the libraries, you can build the libraries of S-frames and they'll show libraries in there. The problem is the dynamic linker, the ld.so, or well, when you run an application, the interpreter will actually execute, look at what files need to be linked, and it will dynamically link the libraries it use, like libc and everything else, into the application address space. And the problem here is the kernel doesn't see it. The kernel has hacks to find out, but those are hacks. We want a system call that the dynamic linker can actually tell the kernel, hey, this file I just loaded has an S-frame section for this text block. Here it is. Now, like with everything else, once you have a system call, it becomes ABI. In the Linux kernel, if you ever heard Linus Torvalds would always say, don't break user space. The major thing is once there's a system call and people start using it, it's there forever. So if we introduce a new API, we must support it forever, which means that you don't want to be lazy or kind of sloppy with that because you're going to regret it later on. So we need it extensible. Currently, the thing is, the simple approach right now we have is for this linker, we could just say, hey, here's the address space that we want, or here's the text space, and here's the S-frame that it matches. That's right now for today. That works, that's great. So we could pass in a range, how we want to do it, maybe address size of the text, address size of the S-frame table. There could be multiple libraries, and you would need multiple S-frames. So you'll need a system call per S-frame table, and they could be, and then also, it is possible, we found out in one of our discussions talking with the GCC and glibc maintainers, that a library can, right now, your distribution libraries don't, but there are some people like to be crazy. If you understand the ELF format, ELF usually has a single PT load section that pulls in because it could go anywhere in the virtual address space, but the PT load, well, some libraries could have multiple PT loads, which means that you have multiple texts, but only be one S-frame. That's why maybe cover all of them. We're saying maybe in that case, we'll still just do a single system call for each of those loaded sections with the S-frame. That still kind of works, the system call that says, here's the text range, here's the S-frame range for that. Now, looking in the future, what other things could we have?
The other one would be having multiple PT load segments,
That's right.
each with different S-frame
Yep.
that describes them. And another one is having one huge PT load segment that's larger than 2 GB that would end up being required to be split into subparts of 2 GB, each with its own S-frame description.
Right.
So
Well, that's an S-frame problem right now because S-frame can't handle itself, so a text section with more than 2 gigabytes.
But that would be a workaround that for that problem.
No, because I don't think it can. The S-frame itself can't do. You
No,
have to
because
change it.
the offsets are
Yeah.
relative to the S-frame,
Yeah.
so we need a new version of S-frame
Yes,
to handle
yes.
that. Yes.
So the question is that, and so that I think right now I think that's easy. Of course, we might want to have a flags parameter, which may always be 0. I don't know what. But we also S-frame. There's a couple of things that S-frame so you do. We want a system call. This might be the same system call to say, tell the kernel. Might be a different. I don't know if you want to show the same system call or different.
Same syscall for JITs.
No, I'm saying this is for, one thing that the GCC folks said, what would be great is have a system call say, give me a stack trace of me right now.
Oh, yeah.
That might be
That would be a different one.
I think that'd be a different system call. So
Especially
basically-
for things like seccomp. So
Yeah.
you may want to allow registering S-frame, but not taking
Right,
a stack trace, for
Right,
instance.
so
Yeah.
here's another system call that we're looking at having, is if you write a library, you want to see who calls this function, you could have that library do a system call and it goes into the S-frame unwinder and says, here's your stack trace. And instead of sending the stack trace to ftrace, LTTNG, or perf, it sends it back to user space. So you can actually see your own stack trace. Yes?
I want this, but for other thread in my central. So I have multiple thread. I
Yeah.
have one of these thread. I want this for
Other
other
threads.
thread in the program.
Well, the thing is, the problem with that is S-frame only works for the currently running executable. Now, the other thread...
No, so what it
What?
could do is send a signal to the
Like-
other thread.
Yeah.
Oh, if you send a signal,
wait,
then they
yeah.
have the signal to do that, yeah, and then return back, yes.
But the idea would be to wait for the completion of
Yeah.
what running on the other
Just
thread.
ask the kernel to give me a stop walk of other threads, singling threads.
Yeah, but the
I
thing,
can
well,
refer-
yeah, but it has to be like a way to stop the thread, because this happens, the logic requires that the stack walk happens on the current task.
Yeah.
So you still have to send a signal and then have something happen on, like have that thread stop and then do the stack walk on it.
I need to stop it and do it in a single handler, for example?
Well, no, like either in a single handler, yeah, but I mean, yeah, you have to send something, so like I said, the stack walk has to happen on that thread.
Yeah.
It's not like I'm saying by the thread. You can't have
Oh.
one thread on one CPU saying, give me a stack walk on another thread on another CPU.
Yeah, because that thread may have to resolve a page fault.
Yes.
It couldn't be delayed. Like
And the stack walking I showed you
Yeah.
is all the logic and synchronization is based on everything happening on that
Yeah.
there. So it's not SMP safe.
So I need to do execution on that thread.
Correct.
And call this is called on that thread.
Yes.
Uh,
Yes. So you can't. No, there's no support for. Hey, give me a stack walk on that thread. Yeah, that's
Even
not.
with ptrace?
What?
Even with ptrace?
Ptrace you can do that, but then you don't need S-frames. But that's one thing. But now another thing is, as what you were saying, is the next layer of this system call that we'll do is JITs, where you have something that actually takes bytecode, it compiles it into a just-in-time automatically, and then executes it. So this is code that does not map to a file, it maps to user space. Now we want S-frames, or at least something similar like S-frames for that. May not be S-frames, may not be the true S-frame format, but it might be similar. So when the stack walk goes and we look at the instruction pointer, and the instruction pointer happens to be sitting on something that was, JIT compiled, then that could be something that we have another lookup table to do that. Now, for applications, there's a few problems here. One thing is, JITs can happen, like it compile a bunch of things. We don't want to make a different system call for every time it compiles. So it's going to have, I'm looking at this system call, the system that we have has to have a pointer to an address that just says, this, maybe that's what have the ID, maybe like that's what we'll have to identify, or if it's an S-frame, if it's a
Yeah, we'll
JIT.
have to see.
yeah. And then we have to have maybe another thing like what type of JIT it might be, like might have two or.
And also how much data is populated. So how much is reserved, right, in terms of S-frame, area, and
Well,
whatnot.
like I said, well, here's the thing that we're actually talking about. So one of the things I'm saying is, what I like about this, what you said, you have the type information in there of what this points to. Now, since the kernel has to read user space to figure this out anyway, you could put a lot of instead of passing information to the kernel via the system call, you could just have a header at the address space that says how the rest of this address space is filled out. So we're just saying the system call will have an identifier saying what type of object this is. And that object will probably have like a header that says that matches, so you make sure that this has like some number and that number matches, that this is the type. And then it has a format that's a contract. This has to be documented because this is an API, but this document
ABI.
What?
ABI.
ABI, yeah.
Yes.
The ABI that the rest of the format is defined by a header. So this way actually makes it much more flexible because we can actually define something that's very simple and says, this is the way we're going to do things. And all I have to do is add another bit or another number and say, hey, this header has a new number, and then we can define any way we want. So maybe this will be the flexibility of the system call. I don't know, anyone else have any thoughts on this? Or, I don't know, it's kind of hard when you first hear something and you haven't been thinking about it, so.
The initial JIT behavior I would intend to support is a behavior where a JIT really populates code into a growable text area, and eventually, even if it stops using some of that code, making it effectively dead or unused, I would not go into the trouble of allowing kind of reuse of those areas in a fine-grained fashion. So it would more be like a generational type of JITting, where you populate an area, and then at some point, if you want to do some changes, you register a new area, and then the old one eventually dies if nobody is using it anymore. So if additional JITs have more, I would say, niche, fine-grained use cases where they want close tracking of entries that are removed, reused in a very fine-grained fashion, that may come as a new type of region registration.
Here's a question for the audience. I don't know, anyone here work with JITs?
Kind of.
Have
Lex
any?
Buffer is a kind of a,
What's that?
yeah, Lex Buffer in Apache is kind of a generic code as well. I would be.
Yeah. But the question is, what would, if you wanted, another thing is, the other question that has, I don't think we really mentioned was, okay, you have an address space and there's a JIT. We need some also information about how do you map that to something that's a human could understand. So if you have a JIT table or something like that, yeah, here's the address for this compiled program, you need to have some sort of symbol table that you could also have in there.
Yes.
Counter question then. Would this be something that, let's say it's completely opaque and obscure to humans, would the information be there to resolve it later? Like post-mortem?
Yeah.
So that's something that the responsibility can go to Colonel Sharp, Trace Compass, and what have you.
Yeah, but the thing is, we have to define that
Yeah.
now. I mean, yeah. I'm saying is we need some sort of way to say, how do we make the identifier point to something that can be translated?
Yeah.
So that has to be part of the contract.
Yes, exactly. That's the thing, and it makes it a lot easier for the visualizing side
Right.
too, if there is context.
Right.
Yes.
So I agree, but we're the ones responsible for figuring out
yeah.
how to do the internals.
But that was it. I kind of understood that you were going to expand it at the writing level instead of.
Oh, no, well, no, the writing level, well, the thing is, if it does have like some sort of table or something, and the point is of saying like, how do we export, or how's that information? I mean, if you have a JIT that says, okay, we record, here's the address spaces, okay, it's in the trace. What's the other handle that's going to say that, how do we, where does that information get decoded?
Some like, what's the name of the function in
Yeah.
terms of
Right.
telling a human what this
Right.
actually means?
Because if the JIT is doing it, only the JIT knows. So that means the JIT needs to put some information somewhere, like have a symbol table that it has to create, that has to, at least a side channel can actually look at, or another event can go and say, oh, this is the first thing we're going to go and, or have some way of setting a side channel up too. And that's like that's the thing I'm having the argument with Linus about too, is we're having stack traces, how do we take these individual numbers and put them to a name to a file?
Yeah. I mean, there are two main approaches I see. One would be kind of stack-based, where the JIT keeps track of what's current in terms of what are the objects that are alive at
Right.
any point. Another approach would be to have the JIT, when it emits the code, it would also emit metadata on the side. That would basically, for a range of IP in the JITted code, say, well, this is the actual symbolic information that's associated. And then we just somehow register that to the kernel, make it somehow typed perhaps per JIT type. So each JIT could have its own kind of table that represents its own symbolic information. We'll have to see with the JIT people.
That's the only thing I'm bringing up, more of an FYI of like what we're working on for the next step. And right now, the thing is, before S-frames could go into the kernel, this system call has to be done. Whether or not, we don't need to have the JIT code written. We just have to make sure that system call can be extended to do that in the future without changing the system call now.
Yeah, that's what's fun with system calls.
Yes.
You want to think ahead a lot.
So that's where we're kind of stuck right now, is how do we get, because right now the SRAM code is pretty much done and we could get it in. It's the system call is the last like block for the normal static SRAM calls for the libraries. But, well, that's it. Thank you.
So people wanted to see the FPGA trace. That was another topic for Unconference.
Oh yeah.
So maybe we could show that. Not sure how.
Can you do screen sharing where
Yeah.
you have teams and
Maybe. I'll try to see. Ça faudrait que tu montres mon écran.
yes, Tracy's